Hello there. This is the second in a series of video posts where we explore diagnostic process mining, that is using the data in our event logs to find out the true causes of the problem we uncover from a descriptive process mining. In the first post, we spoke about why this causal analysis is extremely important. Without it, we run the risk of wasting resources, implementing solutions that fail to address the problem's true cause and could potentially worsen it. We also briefly outlined a 6-step process that starts with defining the problem, then finding and validating the causes. Subsequently, we find appropriate solutions and validate that these will solve the problem before implementing the solution. In this post, we'll focus on defining the problem. Let's start by explaining what we mean by a problem in this context. Simply put, a problem is a gap between expected and actual performance. To illustrate, assume you're working for an online retailer who guarantees to deliver purchased goods to our customers the next day. Internally, the goal, the expected performance, is 99%. So 99% of orders will be delivered next day. However, in reality, only 50% of orders are. That gap between the expected and the actual performance is the problem. Now, operational problems typically fall into one of three categories. Non-timely delivery, as we just discussed, defects, that is the process output failing to meet specification, or longer than expected processing times. However, there are other categories of problems, and throughout this series, we'll be illustrating the causal analysis and inference techniques using a real-life event log from the Business Process Intelligence Challenge from 2017. This is the event log for a loan application process for a Dutch financial service company. Let's briefly walk through the process, and we are focusing on the offer part of this process. This sub-process starts when an offer is created, which is then sent to the customer. Subsequently, the customer is contacted, and then the customer either accepts or declines the offer. The implied problem is that the acceptance rate is lower than expected. So let's walk through an example of how we would define this problem and obtain a problem statement. In essence, we define the problem by obtaining answers to these 5 questions. First, what is the actual performance? Second, what is the expected performance? Third, what is the impact of the problem? In other words, what pain does this problem cause? Fourth, during which time period did this problem occur? That is positioning this problem in time. And finally, what was your data source? Let's illustrate how we obtain these answers from our event log. But before we dive into the details, I will mention a simplifying assumption I have made. We've assumed that the company makes a single offer per application, which is either accepted or declined by the client. In reality, the company makes multiple offers for clients. However, for the purpose of analysis, we filter these applications out. Retaining those applications will introduce an unnecessary level of complexity, and as the overriding aim of this series is to keep things simple to understand, we will remove those cases. So let's look at our first question. And this table here shows all single offer cases and groups them into those who've been accepted, those with a value 1, or decline with a value 0. I'll pause for a moment to allow you time to work out what percentage of cases were accepted. Did you come up with this number? If you did, great, we're still on the same page. That second question, what is the expected performance? Well, for your project, I'll expect you to obtain that information from your process owner or your project sponsor. However, for this process, I don't have access to the process owner, so we'll assume an expected performance of 90%. Now, that seems a reasonable target, given that the customer has gone through the trouble of putting in an application, the company has assessed the application and made them an offer. So it's not unreasonable to expect that the vast majority of customers will accept that offer. So our third question, what is the impact of the problem? What pain does it cause? To keep things simple, we assume that for every euro lent, the lender earns interest of 1%. This table here shows the projected interest income for accepted and declined offers. Note that if the target is met, then the lost interest income is 2/3 of the interest income for declined offers. So by missing the target by that amount, the lost interest income is 637,000 euros. That's 2/3 of 955,000 euros. One point to make here is that problems often have multiple impacts. So an on-time delivery problem might result in complaints and customer churns. A quality problem might result in additional regulatory oversight or reputational risk. It's important to capture the full impact of the problem and fully document these. For our fourth question, over what time period did this problem occur, we see that the timestamp for the earliest activity in an event log, beginning of January 2016, and then the end timestamp at the end of January 2017. So our time period spans 13 months. Our fifth question, what was your data source? We assume that our data is from a fictitious system, XYZ node system. So we put this together and we derive this problem statement. During the 13-month period ending in January 2017, 72.5% of loan offers were accepted. Compared against the acceptance target of 90%, this resulted in 637,000 euros lost interest income, and we specify our data source. In summary, a good problem statement has the following attributes. It's clear and concise, no more than 3 sentences. It's quantified with metrics. It's not vague or woolly. It clearly identifies the gaps in performance, references a time period and data source. It relates to only one problem metric, and it includes the impact of the problem. So having fully defined our problem, how do we find the various causes of this problem and the contribution of each cause to the problem? Well, that will be the subject of our next video post. Hope you'll join us.